Hey, welcome back to Fat Mama Physics. In this video, we are going to do order of operations with powers. So this is section 2.3 of unit 2. So, let's begin. This video I may break down into 2 to 3 parts so that it's not very long. Maybe 3 parts to really be able to chunk it off. So, of course, we will begin our video with kind of the big idea and maybe just kind of like a tactic or strategy which will be featured in this lesson. Aside from Bedmass, there's actually one other thing I want to show you. Since you've already done Bedmass before and it's just now that you have exponents, you know more about exponents, you probably want to apply them in Bedmass and your order of operations. So the one thing that you may or may not have seen before is what happens if you have a big division sign. Like you have a big long trail of things on the top and a big long trail of things on the bottom of this big division sign, and say you have some weird thing that looks like this. What do you do? How do you apply Bedmass? The idea is that whenever you have something on the very top, imagine that you have these invisible brackets at the top, especially say you have something maybe like this. Okay, so imagine you have something you're dealing like that. Imagine you have these imaginary brackets on the top and the bottom, and think of it as you want to do everything that you can to the top and everything you can to the bottom before you do your final division step to simplify. So that's kind of the big the new thing that you may or may not have seen before. And of course, the company board game that I will feature in this video took a while to think, but I have chosen the Attack on Titan deck building game. And because there's these walls that are featured here, it kind of showcases that division sign. So let me go over here to the video, okay? Okay, so here we go. Let's take a look at what we have. So this is the game, Attack on Titan deck building game. So the reason why I picked this one is because it has some features of it has some very structural boundary features which really help to visualize what each part of a boundary represents and what you have to do. So here's the deck building game, the setup. Just from the setup you notice that there's a big wall here. So representing here Wall Maria, Rose, and Sina from the actual anime itself. So in front of the walls, of course, we have these titans. And I just ran out of space here, so I had put all my characters over here, which there's more choices than those, but just for choice. And everything behind the wall is there, so resources you can pick up. Including people, equipment, and different maneuvers. Okay, so what should we say here? What do we got? The protagonists, which of course are these people, what they want to do, what the objective in this game is, yes, to defeat all the titans, but notice there's this big deck, and when this deck is being drawn, you either get people that appear or resources that appear on the safe side of the wall, and then you get these titans that appear on the outside, so it becomes a random draw. I didn't shuffle these guys in, but you can take a look that ultimately you're going to get some arch enemies which will appear. So that includes the Colossal Titan and some other, there are other smaller ones, the dinky ones, and of course we always start off with a Smiling Titan. Okay, so just that's basically these arch enemy titans is what you want to defeat. After we defeat the arch enemy 4, which is the biggest the biggest titan, I guess, in the game, then the protagonists win. Okay, so that's how the game is won. Is once these guys come out, yes, they wreak havoc, but after we defeat them, then it becomes clear. It becomes more peaceful. and that's how we win. So over time, as the course of the game, it's a deck building game, so you start off with a deck of 10 cards, so some courage and some thrust, which give you power and movement. Movement helps you move across the walls and between the walls, and of course the powers help you either purchase the resources with the tags here on the bottom showing how much they cost, and also helps you defeat titans, as you see here on the bottom, as well as how much you need to kill them. So and then after one turn you draw about 5 cards. So let's say this is my hand. That's a crappy hand because of 2 thrusts in there. And then during your turn, let's say I am Levi and I am, say, here for doesn't matter what reason, but essentially when I can be anywhere. I can be here to pick up this resources. I can buy 3D gear anywhere I want. I may pick up wounds. Picking up too many wounds means you have a higher chance of dying if you draw 2 of them or any time during your turn. So that is so that's kind of the basics. How this relates to the idea of inside and outside the walls is that whatever happens outside the walls happens outside the walls. There might be some times that might ambush a district, but that's just some other detail that, of course, you have to play the game to kind of go into. But the idea is that you have to go outside of the walls to fight the titans, and then you have to be inside the walls to buy your resources. It's a very separate, and you kind of do whatever you got to do at every section. And if you think about it, these walls are technically separated. I just don't have space to separate them out. So imagine every set of walls is like a term. In every term, you have a whole bunch of stuff that's there. So it's as if each of these are, imagine the wall is like a division line, which is like in the division, in the fraction that you saw earlier. And then this is above the fraction, this is below the fraction. And you kind of have to deal with everything on this side first before you deal with the other side. So, this becomes very asymmetric in this case, where you kind of have to deal with its titans, otherwise it will actually damage your wall. Because if you don't deal with them, at the end of the turn and the round, they take away one of these wall tokens. Once the wall tokens are all gone from this wall, then this wall collapses and you lose all the resources, as well as all the wall, as well as the entire district. So that is not good. And usually what you want to do is, in case you want the wall to collapse, or if in case you can't defend the wall, then you kind of want to, it's in your best interest to kind of clean up the resources so you don't lose them. And then after the wall does collapse because the titans are, there are too many titans, then this wall just completely goes away and this titan kind of moves somewhere else. But there's other rulings with that. So anyways, that's the idea. Before you collapse or you do the division, you have to take care of both sides of the wall, and that they are also separated from one another, just like they are separated by the division, and how you want to deal with brackets first. So dealing with the brackets before you deal with the division, okay? So, here you go. That's a game. So let me turn this off. Here, zoom in on Captain Levi. Yes, okay. Okay, I would clean up the game, except my time is ticking for us with this lesson, so I'm just gonna keep moving on here, and I'll clean that up a little bit later. So, here we go. Order of operations with Bedmass. So now that we've learned some exponents, you have that step after brackets becomes more prevalent, or you'll notice that you'll be actually doing that step in your order of operations. I will do some examples and maybe you'll do some. So this is just practice. So I'm gonna do maybe some examples, pause it, and prompt you to pause, and then keep moving. So I'm gonna start off with, I'll do B. I'll probably do, actually no, B is a little bit too straightforward. Let's do C. Oh, well, you know what? I end up doing all of them. So let's just keep going. So with addition and subtraction, of course, adding and subtracting goes later. So here we do exponents first, since it comes earlier in Bedmass. 3 to the power 3 is 27, plus 2 to the power 3 is 8. So that's just adding. Then we do the adding, which is 35. Okay, pretty straightforward. Here I get 3 minus 8, and since I'm going to be, and ultimately that's just going to give me -5 after I do that. So notice I write out the exponent, I evaluate the exponent first, and then I do the adding and subtracting. Now there's brackets, so I do whatever's inside the brackets, which 3 plus 2 is going to be 5, and then I keep the brackets just to be sure, and then that to the power of 3 gives us 125. Next up, we have this one. So again, we deal with whatever's inside the brackets first, and if whatever's in the brackets is exponents, then we're going to do that first. So, this is going to be funny, but I'll do all of it anyways. 9 to the power of 3. So 9 times 9 is 81, and then that times 9 again is going to be, 9 times 1 is going to be 9, and then 9 times 8 is going to be 72. Okay, so there you go. And then plus 4 to the power 2, 4 times 4 is 16. And on the other side, we get 4 to the power 2. 4 times 4 is 16. Minus 4 to the power of 4. Oh, that's 16 as well. Haha, that's very nice. So we add this all to... Oh, don't forget this is raised to the power 0, and this is not. So, I know some of you are thinking, isn't there an easier way? Just 1 second. 1 second. So we do this adding here. That's going to give us 5, and moving that over, that's going to be 4 and 8. Okay, so I get this to the power of 0 plus 0. But wait, anything raised to the power of 0 is just 1. And 1 plus 0 is just equal to 1. Oh. Haha. Now you might have been thinking, oh, Miss Lee, you're so silly. Couldn't you have just said that was just equal to 1, since you didn't have to evaluate everything inside the brackets? Anything raised to the power 0 is still going to be 1. You're totally correct. So if you had done that, that's what I would have done. But I wanted to show you that how much work you're saving effectively by just saying that this whole thing is just equal to 1. And then plus, and then you know that this is 16. 16 minus 2 to the power 4, which is also 16, then that's going to give you ultimately 1. So if you had done that, then that would have been fine as well. Oh, and I just want to double check. There's a mistake here. So that's, this is this. Nothing carried over. So that's still 7. My bad. Okay, see what that does? If you just equate it to 1, then you save yourself from calculation mistakes too, in case you need to go back and check. Okay, so there we go. Our final answer is 1. Okay, multiplication and division. So I'm just gonna plow through this first one. Okay, B is done for you. Then I'll give you a chance to try. Ooh, yeah, I'll give you a chance to try C all the way to F. Okay, so let's do A together, multiplying and division. Oh, this is sneaky, but anyway, so here we go. So 2 to the power 3, that's going to give us 8. Okay, so again, since there's multiplying and dividing, we always do the exponents first. So that's going to be 8 times, and this is going to be -2 times to the power of 3. That's effectively going to give us -8. So ultimately -64 as our answer. So number B is done for you. And notice for B, even though there's sometimes you might have exponents on the outside of the brackets, we always do whatever is inside the brackets first. So inside the brackets, we have one number here that is that has an exponent. So we're going to evaluate this exponent first, which gives us -27. And then this multiplied by 2 is going to be -54. Then we do the adding and subtracting, which is the minus the 6. We get -60. Then we apply this exponent on the outside. Okay, and that gives us the 3600. So the steps would be: do you have a bracket? Then do whatever's inside the bracket. If the bracket has multiplying, dividing exponents, then go down in that order inside the brackets. After you are finished with the brackets, then apply whatever's outside of the brackets, including any exponents and adding and subtracting, etc. Okay, so that's the workflow. Then let's deal with, so here is a good chance for you to pause the video to try C all the way to F. Good luck. Okay, so now I will do these ones together with you, okay? So looking at this first, there's no brackets, so let's do exponents first. So negative 2 to the power 4, that's just going to be positive 16 since the exponent is even. Subtract, and here we have negative 3 to the power 3. Since this is a negative in brackets to an odd exponent, this is still going to be a negative answer, and that's just going to be 27. Okay, and then divide negative 9 to the power of 0, that's always going to be 1, very nice. And then multiply to the power 3, that's going to be 8. Okay, so here we go. Okay, so now that we have everything in outside of the exponent, no exponents now, so just multiplying and dividing. So if you go by Bedmass, D goes before M, so we're going to have to divide first, which effectively doesn't do anything since this is just dividing by 1, but let's show the work anyways. So that's going to be minus negative 27, and divide by 1 will be just itself. So that effectively gets rid of dividing by 1 and multiply by 8. So next up, what we have is we have this. That's the next step, which is multiplying. And notice I didn't have a negative sign included in there, so that's just 16 minus whatever 27 times 8 is going to be, which we know is going to be negative. So this is going to be 6, 5, and 21, if I did the math correctly. Okay, and then bracket this off. So now I have 16 minus negative 216. This is effectively 16, and I have two negatives. That makes it positive plus 216. And adding these two together, I'm going to get 232 after I add them together. Okay, that's our first example. Yay, and it's negative and it's positive. Okay, ooh, this one we're just dealing with tens. Very fun. So again, brackets always come first. So we have 10 to the power of 2 divided by 10 divided by negative 2. That's just going to give us negative 5 to the power of 2. So now we apply the exponent on the outside of the bracket, which is going to be, and this is negative inside, and to the even exponent, a positive 25. Notice after every step, I'm including this equal sign just to show one step at a time. Here, oh, and guess what? I forgot to apply this exponent. Even if I did it earlier, oh, right, I would have done it here. So that's just 100, okay? So that's 100 divided by 25 gives us 4 as our final answer, no negatives. Okay, example E. Let's do brackets first because we have some brackets. So inside the brackets, we have 18 times 18. I'm sorry, I'm just going to do this here. 3, 2, 4. 3, 2, 4. 3 to 4 plus 5 to the power of 0, that's going to be 1, and all of that to the power of 2 divided by negative 5, and as a base to the power of 3. So next up we have to clean out the brackets again. So this is 3 to 5 to the power of 2 divided by negative 5 to the power of 3. Okay, now we're done brackets. Now up on to exponents. So 3 to 5. Okay, let's do 3 to 5 to the power of 2. Oh, 105, 625. 105, 625. Divided by, this is negative 5 to the power of 3. So my answer is going to be negative, and 5 to the power of 3 is just 125. So take this number, divided by 125, and 845. So notice I didn't put in my negative because I know that my final answer is going to be negative anyways. You just have to remember that, otherwise you will forget that it's negative, and it's important that it is, okay? Last but not least, F. Wait a minute. This whole thing is in brackets. And raised to the power of 0. So I don't even have to evaluate whatever's inside, because I know everything raised to the power of 0 is 1. That's f. Done. Woohoo! Okay. So I believe I'm going to conclude my video here, and I will do the next page in the next video. So I guess this will be 2 videos, not 3. Sorry, I went a little long there. Okay, so thank you for watching, and stay tuned for part 2. Wish you the best of luck. Thank you. It's been a long day. Thank you for watching, and Fat Mama Physics signing out.